Amazon EC2 provides a wide selection of instance types optimized to fit different use cases. Instance types span various combinations of CPU, memory, storage, and networking capacity. They give you the flexibility to choose the right combination of resources for your applications. Each instance type includes one or more instance sizes, allowing you to scale your resources according to the requirements of the target workload. Therefore, when you create an EC2 instance, you have to choose how much of each of these components it needs. Instance types are grouped into different instance families, and we'll look at these families in a minute. Then, you should select an instance type based on the applications you plan to run on the EC2 instance. For example, if your application is compute-intensive, you should select a compute-optimized instance type. If your application requires a balance between CPU and memory, you should select a general-purpose EC2 instance type. So, before we look at the available instance types, let's talk about the naming convention for instance types. Here's an example. N6i large. The first letter, in this case M, represents the instance family. The instance type M belongs to the general-purpose instance family. The number following it, in this case 6, represents the generation, and the letter following it, in this case I, is the attribute denoting the additional capability. The instance type M6i large has an Intel processor, and that is represented by the attribute I. The word large represents the size of the instance. In this case, it provides 2 vCPUs and 8 GB of RAM. Let's look at one more example, C5 large. The letter C represents the instance family, in this case compute optimized. The number 5 is the generation. This instance type has no attribute indicating additional capacity, and 9 large is the size of the instance. In this case, it provides 36 vCPUs and 72 GB of RAM. Now that we know this important detail, let's look at the family of instances available. Therefore, starting with general-purpose instance types, they provide a balanced mix of compute, memory, and network resources. In addition, they can be used for different workloads. These instances are ideal for applications that use these resources equally, such as web servers and code repositories. For example, imagine you have a small business and need to host your website. A general-purpose instance type would be a good choice, as it provides a balanced mix of compute, memory, and network resources to run your website efficiently. Compute-optimized instances are designed for workloads that require high performance in batch processing, media transcoding, high-performance web servers, etc. Memory-optimized instances are designed for applications that require large amounts of memory, such as databases, distributed caching, and business intelligence applications. For example, imagine you have a database that requires large amounts of memory to function properly. A memory-optimized instance type would be a good choice, as it provides large amounts of memory to run your database efficiently. Accelerated computing instances are designed for workloads that require hardware acceleration, such as machine learning, graphics, and real-time processing. For example, imagine you are running a machine learning application that benefits from hardware acceleration, such as GPUs. A compute-accelerated instance type would be ideal in this case. Storage-optimized instances are designed for applications that require high storage performance, such as transaction processing OLTP, relational and NoSQL databases, and so on. For example, suppose you have an application that needs to perform a lot of read and write operations to disk, such as a high-performance database. A storage-optimized instance type would be the best choice. Finally, high-performance computing-optimized instances are designed for workloads that require high performance in batch processing, media transcoding, and high-performance web servers. These instances offer high compute capacity and high-speed networking to run HPC applications efficiently. Typically, these types of instances are used in fields such as molecular dynamics, computational chemistry, weather forecasting, material simulation, crash simulations, astrophysics, etc. For example, imagine you are a scientist working on a molecular dynamics simulation to better understand how molecules interact in a system. This simulation is computationally intensive and can be very time-consuming if run on a normal computer. However, by using an HPC-optimized instance, you can take advantage of a high computational capacity and high-speed network to run your simulation faster and more efficiently. This allows you to get results faster and advance your research.